have one more special pattern that's going to be pretty important for you to at least be able to recognize. Okay, so I'm going to give you an example once again, and then I'll talk about the formula. Okay, so if I have x squared plus 6x plus 9, okay, and I'm just worried about factoring right now. Okay, I'm looking at that. There's no great common factor. I'm going to do my x. I'm going to say, okay, a times c goes here, so that's 9. Okay, b goes here, so that's 6. So what multiplies to give me 9? Has to give me 6. That's 3 and 3. So I'd write it as x plus 3, x plus 3. Now, I would like to rewrite that as simple as possible, so ultimately this is the same as x plus 3 squared. Okay, the way that we can recognize what we call perfect square trinomials is there's a special pattern. Okay, perfect square trinomials. There's a special pattern to it. So we'll have, you have a squared plus 2ab and then b squared. Okay, or you could have a squared minus 2ab plus b squared. Now that's a lot of letters. Okay, but don't let that confuse you, because ultimately the two ends have to be perfect squares. And if the two ends are perfect squares, then you want to test the middle term. All right, so in this case, a squared is going to be x squared. Okay, it's making ax. B squared is 9, making that 3. So x times 3 is 3x. Is this term 2 of those? Is what you're looking for. Okay, do you have 2, okay, of these two combined? In this case, you did. Okay, so 3x times 2 gives you 6x. Now, this one isn't all that bad because you can use the x and you do it really quickly and you can see it. What happens whenever you get numbers that are a little bit more complex? Okay, so I'm looking at 4x squared, okay, plus 28x plus 49. I'm going to go ahead and set that equal to 0 because we're going to solve this. Okay, that would be a very large x. Okay, if I'm going to use my big X, I've got to multiply 4 times 49. I've got to figure out what multiplies or adds to give me 28. Lots of things going on here. So I always want to look and say, okay, well, is there greatest common factor? No. Is the set equal to 0? Yes. Are the ends perfect squares? Yes, they are. Okay, so in this case, I'm looking at a squared is 4x squared, which means a is just 2x. Okay, so 2x times 2x gives me 4x squared. In this case, b squared is equal to 49. But don't worry about the letters. I realize that's actually a c value. Okay, please don't let that scare you. Okay, I'm just talking about just the number at the end. Okay, just whatever that constant number is at the end. Okay, so that means b is going to be 7. So when I multiply 2ab together, I get 2 times 2x times 7. Okay, well 2x times 7 is 14x, and 2 of those would give me 28x. Hey, that's what I have in the middle. Okay, so this is what we call a perfect square trinomial, because this middle term is 2, okay, of the square roots of these guys multiplied together. So without having to go through my big X, I can say, all right, a, okay, plus b all squared. Okay, a plus b all squared. So let me break that down. I'll go back up here. Okay, this is the pattern. Okay, and this would be the solution. A plus b squared. If this is the pattern, then this is the solution. All right? Now realize that's tricky. You can still use the big X, but it's important that you recognize, oh yeah, those are perfect squares, because we're going to use that here in a few weeks. Okay, remember, I know what's coming up. Okay, you don't. So you think that you're going to, oh, I'm just going to make it easy on myself. I'm going to do the same thing. But I know what's coming. I'm trying to help you guys out. All right? Oh, I kind of skipped that a little bit, didn't I? We should have solved this. Okay, so ultimately this is the situation where you only get one answer. Okay, because when we set that equal to 0, you would say 2x plus 7 equals 0. So x equals negative 7 halves. That is your only solution. So with perfect square trinomials, we actually only get one answer, which is pretty unique. Okay, so just kind of be aware of that situation. All right, so last example. Okay, let's see if we know how to do this. Is there greatest common factor? No. Is a set equal to 0? Yes. Okay. 3 terms, so definitely not a difference of squares. All right, I know I have an a value, so I'm either going to do a big X or I'm going to look at the ends. Okay, perfect square. That's a perfect square. That's a perfect square. So that would mean a is 3y. That would mean b is just 2. Okay, I'm just taking the square roots. Okay, now ab is going to be 6y. If I multiply that times 2, I get 12. Yes! Okay, that is what I'm looking for in the middle. So, I'll say 3y minus 2 squared. Okay, I'm just doing minus because the b value is negative. I got to kind of take a look at that. Otherwise, it doesn't work out. Okay, so 3y minus 2 equals 0. You would add 2 and divide by 3. So you get y equals 2/3. Okay, x, y, okay, it's just some variable, all right, for you to be able to solve for. Now, if ultimately you're looking at going, Coach Semino, there's no way I'm ever going to be able to remember that, you can use your big X. It still does work, all right? So we will have what multiplies to give me 36, what adds to give me negative 12. Well, that's going to be, looks like a negative 6 and a negative 6. All right, so I'm going through the same process. I'm going to say x minus 6, x minus 6. You're always having to divide by the a value. In this case, the a is 9. So this becomes x minus 2/3 and x minus 2/3. I can't leave it like that because you can't have fractions there. So you always move the denominator to the front. So you get 3x minus 2 and 3x minus 2, which is what I have. 3x. I'm going to change the variable to x, but it should be y. That was just a slip. Just used to dealing with x. So 3y minus 2 squared. Okay, so you get the same answer, but if you can recognize the pattern, it's going to be faster for you ultimately.